In this question, we have to find the RMS value of the resultant current in a wire which carries simultaneously a DC current of 10 ampere and an sinusoidal AC current with peak value 10 ampere. Suppose this green graph represents an AC current of 10 ampere amplitude, and this pink graph represents a DC current of value 10 ampere. Then if we add these two, we will get this blue graph which will have a maximum height of 20 ampere, and this is the current which flows through the wire under consideration. Now this function can be written as 10 plus 10 sine omega t, where omega is the angular frequency, time period is this from here to here, and definitely we will have t equal to 2 pi by omega. So this is the current I. Now let us first calculate the mean squared value, that is integration of I squared dt starting from 0 to capital T, one complete cycle, and then divided by total time period T. So that will be equal to integration from 0 to capital T 10 plus 10 sine omega t whole squared dt whole divided by t. This 10 is a constant. I can write 10 squared outside the integration, and then I will have 1 plus sine omega t whole squared, so which will be equal to 1 plus sine squared omega t plus 2 sine omega t integrated from 0 to capital T dt, and then whole divided by capital T. Now let us simplify this and see what do we get. We have here 100 by capital T. Now integration of 1 is T. Okay, before that, so let me write this as integration of 1 plus, instead of sine square omega t, I can write it as half 1 minus cosine 2 omega t, cosine 2 omega t, and plus 2 sine omega t. This is integrated from 0 to capital T. So this will be equal to 100 by T, capital T, and integration of 1 from 0 to capital T will be T, then plus half, integration of 1 will be again T, then minus integration of cosine 2 omega t will be 0. If you carry out the integration, you should get 0. Anyway, it's a periodic function, so over complete cycles, the integration should be 0. The area under complete cycles should be 0, and then plus 2 into integration of sine over a complete cycle will again be equal to 0. So therefore we will have 100, and here we have 1.5. Okay, so into 1.5, and this t from the numerator and the denominator will cancel each other, so this will be 150. Okay, and then the RMS value will be square root of 150, which will be approximately around 12.25. Okay, and this will be in ampere because the current is in ampere.